Dear students, welcome to the next session of operating systems. In this session, we are going to discuss about system structures. Greeting of the day, everyone. This is Dr. K. Praveen Kumar, Assistant Professor, Department of Information Technology, Pittsburgh. In this session, we are going to discuss about operating system services, system calls, types of system calls, system programs, operating system structure, and system booting. Objective of this class is to describe the service of an operating system provides to users, processes, and other systems. To discuss the various ways of structuring an operating system, to explain how operating systems are installed and customized and how they boot. Upon completion of this video, you will be able to explain the knowledge of operating system services and system calls. You can be able to describe the importance of layered structure in operating system development and system boot. First, coming to operating system services. Operating system services provide an environment for execution of program and services to programs and users. So what kind of services? One set of operating system services provides functions that are helpful to the user. What are the services? One set of operating system services provide functions that are helpful to the user through the user interface, program execution, IO operations. User interface. You know already, what is user interface. Whatever the interactive screen you are watching, that is user interface. Almost all operating systems have a user interface. That will vary when you are using the command line and the graphical user interfaces and batch systems. The second one is program execution. The system must be able to load a program into memory and to run the program and execution either normally or abnormally. For example, if it is having some errors, then the abnormality it have to show. That can be done by the program execution. For example, whatever you are running, C, C++, Java, all the programs that will be executed. IO operations. A running program may require input-output, which may involve a file or a device. For example, if I'm to deal with this class, I'm using my keyboard, I'm using my mouse, as well as the input. These are the output devices. The input, I'm taking the web camera and my internet. These are the input devices and input operations I'm doing. So another set of operating system services provides functions that are helpful to the user are file system manipulations, communications, error detection. File system manipulation. This file system is a part of interest. Programs need to read and write files and directories, create and delete them, search them, list file information, and permission management. Just the simple example is whatever the operations you do on the files, all this comes under file system manipulation. Communication. Processes may exchange information on the same computer or between computers over a network. So that is called as communications. So communication may be via shared memory or through message passing. So this can be done in two ways. Next one is error detection. Next service is error detection. Operating system need to be constantly aware of possible errors. What kind of errors is possible, that operating system must be aware, and may occur in the CPU and memory hardware in IO devices in user. For each type of error, OS should take the appropriate action to ensure correct and consistent computing. Debugging facilities can greatly enhance the users and programmers' abilities to efficiently use the system. So this is importance of error detection. Continuation to this operating system services, another set of OS functions exist for ensuring the efficient operation of the system itself via resource sharing, by sharing the resources. In that, the first service is resource allocation. When multiple users or multiple jobs running concurrently, two jobs are running concurrently, resources must be allocated to each of them. Many types of resources may be anything like CPU cycles, main memory, file storage, IO devices, memory management, right? So such a kind of resources may be given to the different jobs. Accounting, to keep track of which users, how much and what kind of computer resources. So if you are allocating different resources to the different jobs, so whenever you are allocating to a particular process, then that must be accountable. That means it must have to maintain a table that so and so process has utilized so and so resources. For example, resource process 1 has utilized the resource of printer. That must be in accounting management must have to take care. The next service is protection and security. The owners of information stored in a multi-user or networked computer system may want to control use of that information. Concurrent processes should not interfere with each other. Protection involves ensuring that all access to system resources controlled, that is protection. Security of the system from outsider requires user authentication extend to defending external IO devices from invalid access attempts. Students, when you are entering into the operating system laboratory, when you want to log in into your Linux operating system, then you have to give the user ID and password. So there, when you are giving the user ID password in the server, it will check whether it is a user that belongs to you or not. So that is authentication. And after that, you can access your terminal. That comes under a security point. This is the view of operating system services. You can see this. This is user interface, and this is system calls. Next, in the next chapter, we are going to discuss about system calls. And these are all the services. This is all services, and this is your operating system, OS, and these are the hardware parts. So what are the different services we have? Program execution we have discussed, input output operations, file systems, communication, that one system can be communicated with another system, just like you are sending the mails, you are sending different messages to another system. Resource allocation, accounting, that how many resources are utilized and which process is using that is accounting. And error detection is when the programs are running in error. Just like sometimes your operating system will give you a message pop-up window that is some so and so DLL file is missing. So that comes under error detection service. And next, protection and security. So whenever there is some attacks onto your system immediately will raise the error. For this protection, your operating system will maintain some firewalls. And of course, you are using some antiviruses that will give you the protection. And the security is to enter into your system, you are giving some with user ID and passwords. So with that, you are giving the security, right? Next one is system calls. Programming interface to the service provided by the operating systems. So typically written in high-level language, these system calls written in high level languages like C or C++. Mostly it is accessed by programs via high level application program interface, that is you call it as APIs, rather than direct system call use. Instead of direct, you cannot call these system calls directly, we'll use APIs. So there are three most common APIs are there, that is Windows 32 API, POSIX API, that is POSIX based for Unix and Linux, and Java API for the Java virtual machine. Windows Win32 API is general for the Windows operating systems, whatever we are working presently, that is Win32 API. So these are the examples of system calls. System call sequence to copy the contents of one file to another file. Whenever you are copying one folder to some files from one folder to another folder, so generally you can see this diagram when you are copying, but internally what is happening? So this is your source file, for example, and this is your destination. When you press Ctrl C and Ctrl V or copy and paste, so this will happen internally in the operating system. What it is going to do? So example of system call sequence. First, it will acquire the input file name. What is the input file name? That is source file name, and it write prompt to the screen. That is we are copying from so and so folder, folder one, and accept input. Then acquire output file name. That is it will get the destination folder name or file name, and it accepts an input and then open input file. If file does not exist, if the file is not there or it is only read only, then it will abort. Create output file, otherwise it will create the output file. If the file exists, if that already the file is there, whatever you want to copy, that file is already there, then it is going to abort. Otherwise, what will be happen? It is going to make it as a loop. In that loop, what it is going to do? It is going to read from input file and write onto the output file. So this will complete till when it will stop, when the read fails. That means in the source file all the contents are completed, then the read fails. Then you are going to close the output file and write complete message onto the screen, that is the copying is completed, and terminate normally. This is what generally happens when you are copying the contents of one folder to another, or one file to another file. Right. Right. This is one more example of a standard API. So these are the generally this will be happen. It is a return value of size t, and this is the function name you are reading. What you are reading, what are the parameters? FD, void buffer, that is size, count. So generally this will be happened inside your API. Right. So int FD here, whatever these parameters, int FD is the file descriptor to be read, where you have to read. Void buffer, a buffer where the data will be read into, and size t count, size underscore t space count, the maximum number of bytes to be read into the buffer. So these are the three parameters, right? So how you are going to implement these system calls? Typically, a number associated with each system call. For each and every system call, a number is associated, and that system call interface maintains a table indexed according to that number. That is, so each and every system call will have its own number, and that will be maintained in a table. 1, 2, 3, 4, and here the system calls will come. Right. The system call interface invokes the intended system call in operating system kernel and return status of the system call, and any return values. Is that system call is going to return any value or not, it is going to check. So the caller need know nothing about how the system call is implemented. Actually, generally the caller who is calling the system call, it doesn't need to know about how the system call is working. Just need to obey the API and understand what OS will do as a result call. most details of OS interface hidden from programmer by API. So you doesn't know what is happening inside when you are copying from one folder to another folder. Everything will take care by your APIs. So it is managed by runtime support library. This is what happened inside API, system call, and OS relationship. So what is happening here? See, right. So this is a user application, and open is a system call. When this open is system call is called, right, we are in user mode now. User mode, that is the interface where you are actually working. So whenever this open system call is called, immediately your system will enter into the, by using this system call interface, it will enter into the kernel mode, and it will check that particular open system call, and it will go through that, and it will implement open system call, and whatever the output of this open function will give, that will be returned to the system call interface. System call interface will give the output to this user application. That means if you are opening a Word file, then open system call will be called, and that will be sent through the system call interface, and that will be sent to the kernel mode, and it will search that file and open. So this will all generally done in seconds. Right? System call parameter passing. Often more information is required than simply identity of desired system calls. Exact type and amount of information vary according to the OS and its call. So three general methods used to pass parameters to the operating system. One is simplest one, and parameters stored in a block, then parameters placed, block and stack methods. So simplest one, pass the parameters in integers. So in some cases, maybe more parameters than registers. So in that case, it will be somewhat difficult. In the simple way, you are going to pass the parameters in registers. But if the registers are less number, if parameters are more, then it will be a problem. Parameters stored in a block or a table in a memory, and address of blocks passed as a parameters in register. So this is one more method. This approach is taken by your Linux or Solaris. Parameter placed or pushed onto the stack. You are using a stack here by the program, and popped off the stack by the operating system. So you are going to push the parameters onto a stack, and then whenever it needs, then you are going to pop that program. That is another method. Block and stack methods do not limit number or length of parameters being passed. So block, and this is the block method, and this is stack method. So both do not limit the number of or length of parameters being passed. So parameter passing via a table. So these are the parameters per call, and load that system call address. Every system call will have its own number from the user program that will be sent to the register, and that will be use these parameters from the table, and that code 13 will call the operating system. So the last one is types of system calls. Process control. In that process you will be having different types: create process, terminate process, end, abort, load, execute, get process attributes, set process attributes, wait for the time, debugger. These are all different types of system calls, comes under process control. Then file management. Create file, delete file, open file, close file, read, write, get, set, file attributes. All these are the system calls which comes under file management, and comes under device management. When you want to manage your devices, there is some other system calls like request device, release device, get device, set device, logically attached device or detached device. These are all comes under device management system calls. Information maintenance. Get time or set time, get date or set date, system data, get system data, set process files or device attributes. All comes under information maintenance. Coming to communication system calls. Create, delete communication connections. So if you want to establish a connection from one system to another system, you have to create the communication channel, and you can, after completion of your communication, you have to delete that communication channel. Send message, receive message, share memory model to gain access memory regions. For all these, you need communication system calls. Protection. Control access to resources, get and set permissions, allow and deny users access. For all this, you'll be having system calls. So these are the examples of system calls that process control system calls comes under this. If you are using the Windows operating system, create process, exit process, wait for signal object. These are the system calls. When you come to Unix, for, exit, wait. These are the corresponding system calls. When you are going for the file manipulation, create file, read file, write file, close handle. Whereas in Unix, open, read, write, close. Like that, you are having several system calls, and these are differentiated when you are using Windows and Linux, but the final intention is same. Our final output is same. So standard C libraries. So these are the standard C libraries. Printf, you know already this. Write is a system call. So this we have discussed in your C languages. So this also calls one of the system call. When you are using this printf, then that will go to the standard C library. Whenever it is getting the code of that, it will enter into the kernel mode, and it will take that definition of printf, and it is equals to write. Then write system call will execute, and that will be sent to your printf function. Next, 2.4 is system programs. System programs provides a convenient environment for program development and execution. This can be divided into several types: file manipulations, status information, programming language support, program loading and execution, communications, background services, application programs. Like that, this system programs divided into several types. Of course, all these system programs we'll discuss in the coming sessions. Most users' view of the program operating system is defined by system programs, not the actual system calls. So system calls is for simple tasks, and most of the operating system tasks will be done by the system programs. Some of them are simply user interface to system calls, the other are considerably more complex. So the different system programs are file management, status information. The file management, we can create a file, delete the file, copy, rename, print, dump, and so on. So these are all comes under file management. Coming to status information, some of things system for information, date, time, amount of available memory, disk space, how much it is filled. That is the status of your system, status of memory or status of your processor. Some other provides the details of performance logging, debugging information, who are logged in, and these programs format and print the output to the terminal or other output devices. Some systems implement a registry used to store and retrieve the configured information. For example, you are installing some software onto your operating system, then you can check by typing registry in your command prompt, then it will take you to the registry. In that registry, whatever the software you install in your operating system, that will be registered. Even though you uninstall that particular program, that will not be cleared from your registry. That is the reason sometimes you need to clean the registry. So that's of course, that's an expert task. Right. So file modification, when you want to modify some files, text editor, like your text editors, Word, process, Notepad, place like that, that will modify your files. Special commands to search content of files or perform transformation of the text. Programming language support, compilers, assemblers, debuggers, and interpreters sometimes provided. That is support for your programming language support. Program loading and execution. We are having some loaders, linkage editors, overlay loaders, debugging systems for high level and machine languages like your C, C++. Communication system programs provides a mechanism for creating a virtual creation among the process, users, and computer systems. It allows users to send a message from one screen to another screen, or one browser to another browser, or one domain to another domain, or one network to another network remotely. So this is done by the communication system programs. So background services. So launch at booting time, all these background services will come under background services. For example, when you are inserting pen drive to your system, immediately a pop-up will come. You have inserted a pen drive and it is having an error. So that is a background service done by the system program. It provides facilities like disk checking, process scheduling, error logging, printing. When you connect a printer, so it is going to give you a pop-up window that your printer is connected with its number. So runs in user context and not in kernel context. For this, to run these system programs, it will not go to the kernel context. It will run in the user context. That is the reason the system programs run very fast. Application programs, system programs, that is, it don't pertain to system. It is run by the users. That is, application programs are whatever the applications you are installing on your operating system, like VLC media player, Windows media players, and some other softwares, your games, they're all comes under application programs. So mostly that will be launched by the command lines or mouse click or finger poke if it is a touch screen. So thank you. This is all about chapter 2. We'll come up with a next chapter. All the best.